In the last week, thousands of earthquakes have occurred in a small part of the Czech Republic in Europe, and as strange as this might sound, this is actually related to an intrusion of magma. Well, sort of, kind of, barely. You see, the magma intrusion in question is completely stationary and has been that way presumably for a very, very long time. It has most likely almost completely cooled and is probably around 250,000 years old, as that would coincide with the age of the area's last known volcanic eruption. It just so happens to be the case that at depths of 12.5 kilometers below ground, anything including magma will take a lengthy amount of time to cool, sometimes even in the range of hundreds of thousands of years to perhaps even 1 million or more years. The aforementioned earthquake swarm is almost certainly caused by the underground movement of carbon dioxide, a volcanic gas, which is probably originating from even deeper magma. Yet, to make things even weirder, this rising ancient gas won't just randomly trigger earthquake swarms on its own. Instead, it needs to pass nearby or probably through an ancient magma intrusion in the area of a fault zone. If this happens, then the rising fluids can generate earthquake swarms like what we have been observing since November 20th. The earthquake swarm in question has seemingly occurred in two distinct segments which waxed and waned in intensity and were separated by location. The first part occurred in this half-square kilometer area region 3,200 meters east of the town of Luby between November 20th and November 27th. The second part occurred after several days of still elevated local seismicity 2 kilometers to the north-northeast on December 4th and is still ongoing at the present. This secondary phase has been about 6 times as intense in terms of number of earthquakes that have struck, although if you live nearby and hadn't felt any earthquakes, that wouldn't be too surprising either. More than 99% of the more than 5,000 earthquakes that have struck in this swarm have consisted of so-called micro-earthquakes, too small to feel and below magnitude 2. Only about a dozen have been large enough to potentially weakly be felt by those right above its epicenter, with the largest earthquake so far only being a magnitude 3. Still way too small to cause any damage. Regardless, while this earthquake swarm might sound concerning to those unfamiliar with it, it really isn't, and here is why. You know the term earthquake swarm? It describes a series of earthquakes that occur in a small region which do not follow a typical foreshock and aftershock sequence with a rate of events. Well, that term was actually invented in this very region, folklores, from a scientist in the late 1800s who was studying an 1824 earthquake sequence. In other words, while this month's earthquake swarm is comparatively strong, it is by no means unprecedented. The Folklores region is a regional hotspot for earthquake swarms which have occurred in 2000, 2008, 2011, 2013, 2014, 2017, 2018, and now 2025. And that's just the ones in the 21st century. Earthquake swarms have been occurring here as long as thorough records have existed and have been occurring in portions of this outlying 4,000 square kilometer region. While most of these swarms never saw an earthquake larger than magnitude 4 strike, the strongest recent swarm in 1985 saw even a single magnitude 5.1 quake strike. So, while the risk of an actually damaging earthquake is low, these swarms can very rarely produce them. But back to why these earthquakes are occurring. In multiple portions of Central Europe, including the far northwestern Czech Republic, geologically recent volcanoes that formed were controlled by passive rifting in the European Cenozoic rift system. The sub-rift in question is known as the Eger Graben, which covers this approximate region. Here, there is a weak point for any magmatic fluids to be transported upwards through, with partial melt existing at shallower depths in the upper mantle than in other nearby regions. This partial melt releases rising carbon dioxide gas, generating occasional earthquake swarms and sometimes even localized degassing of some of the aforementioned carbon dioxide on the surface. Despite the shallowness of the earthquakes in this earthquake swarm, they have absolutely zero chance of triggering a volcanic eruption in my opinion. A special thanks to my patrons on Patreon and channel members on YouTube for supporting my work.